Hello and welcome friend. In this tutorial we will try to look at some of the other options with respect to find. In the past we have seen how to find a file with respect to name or extension. Now we will try to look for file with some particular permissions. Now let's suppose we want to find a file which doesn't have all the read, write and execute permissions being set. Now, if you're unsure about how to set up permissions, I would request you to go and look at the chapter called chmod and chown and permissions in my tutorial before you proceed with this permissions thing. So let's see, in the current working directory, I want to find a file of type F, which is a regular file as we know from the last tutorial and whose permissions are not 0777. For this tutorial, you assume that this 0 doesn't exist. So it's a read, write, execute for user, group and others. Now this 0 is also needed. This 0 means a permissions with respect to sticky bit. When you are setting up the sticky bit, this is with respect to that permissions. If you don't give, so it means just a regular permissions. There is no concept of sticky bit in this. So this is user, group, others. But when you put 0 or maybe 1, so the sticky bit permission is 1, 0, 2 or 4. So we can either set a sticky bit with this first field, or we can set some of the fields like resident set size memory. We can set a program in such a way that if the bit is set, that program will always stay in memory. It will not be swapped out to the disk. Okay. So that's a different story, but we'll look at the find. So what we are saying is find a file which is a regular file, which means it's not a directory and the permission is not 777. So we have so many files. Now if I say okay, don't give the permissions 777, what if the permissions actually 77? We have only few files which has a permissions of 777. Let's see. Whatever it has given, let's try to verify so that we are sure that we are looking at the right data. This will give us a confidence that okay, we are running the right command. So you see here, this is the right command. It has all the permissions as we were listing. However, if you look at this file, which was a result of the previous command, not 777. So if you look at .file name, it should not have all the permissions. If you see here, it's not 7. So this is read and write, which is 4 plus 2 is 6 and this is 4 4. So this is 6 4 4, not 7 7 7. So that's why it was giving not permissions, was output was this. So it was giving this. When we say permissions 777, I have only few of this. Now when you give a permission 777, which means you're making read, write and executable for everyone. So you should be knowing what you are doing. It might become a security issue if you blindly just give 777. So make sure you understand what you're trying to do. So that's the permission. Now there's shorthand notations that if I want to find out files which has a sticky bit set, so I could say -perm and /u equals to s. What this means is find a file in root directory, which is not just my local directory but in the entire root, whose permissions user has a sticky bit set. /u stands for user. Now since I will be running in the /root command, so it needs access. It will be denied access to many of the files and folders with lots of errors. So I will give a sudo. Sudo is a special program which makes my program to run as a super user. Now I'll give a password. So if you see here, some of the programs has a sticky bit set. Now let's see what is that. If I see here ping, you see here it has a sticky bit set. So that's about sticky bits permissions, finding the sticky bits permissions. Now let's suppose I want to find all the files which has a read only permissions for the user. I could have given like this, find all files which has only read only permissions. And if you see here, all those files, are read-only permissions. By the way, proc file system, you might have seen a lot of contents with respect to proc. Proc is the kernel data structure mounted in so that you can look at all the different kinds of variables, debug informations, devices, PIDs from the kernel. It is just a user space mapped as a user space so that a user can access, of course based on some permissions, user can access the informations from the Linux kernel. Okay, so we were looking at find all files in root which has a permissions for user read only. So if you see here, just to verify, and we can see here ls-l. So you see here it has only a read and write permission. So user has a read permissions, others don't have the permissions. So /u means user has a read permissions. Now if I want to find all files for everyone, it should be execute permissions. So /a means all, /u means user. So if I say here, then you see these files everyone should have a execute permission. So let's see this one L, and then if you look here, you see everyone has execute permission. So one more thing, if there is a directory, you should see that if there is a directory and if you say ls-l on a directory, it will actually show the contents, ls-l contents of that directory. It will not show you the property of the directory itself. So if you say ls-ld, it will show you the property of this directory itself. So in the past, in previous example, when we were saying ls-l, it was actually showing me the contents inside that directory, but it will not show about this directory itself. So if I use ls-ld, it will show me this directory itself. So that's a very important point to note, that when you want to look at the property of a directory itself rather than inside the contents, then you use ls-ld. Now if you see here, this property for the read, write, execute permissions we were trying to look. So you see that this is a directory, it has a read, write, execute for the users, and for others it's not here. So that's what it was saying, for /a for all users it has execute permissions. So it will try to find out files like that. Now if I want to find a file for some particular user, like let's suppose there is a user called John and I want to see all the files which belongs to John. So what I will give find the path where I want to find out with the minus username John, and it will try to find all the files which belongs to user John. So the command is like this. I am giving sudo because I might not have the access to run my command under entire /home. So that's the reason I use super user. So whenever you don't have an access, and if you have the rights for super user, try to run it as a super user, but always ensure when you are running the command, what kind of command you are running, whether it's a destructive command, that rm or something like that. So you have to be very careful while executing those commands. Now let's suppose I want to find a file belonging to user Shakil and the name has the extension cpp. So I could say find dot or any path name. Let's suppose that my path is Shakil bssg, and then I would say minus user Shakil and minus iname or name, and I could say star.cpp. So now if I give here all these files belongs to Shakil and this is a cpp file. So this is like this user. So whenever you want to find a file belonging to any particular user, you would say -user. So thank you all for watching this video, and I hope to see you in my next video. You have a nice time. Bye.